All right, let's dive into a technical breakdown of the Model Context Protocol / Python SDK repository. So, what's its core purpose? Well, in a nutshell, it provides a standardized, protocol-driven way for applications to expose their capabilities, things like tools and resources, to large language models. Here's how we're going to break this down. First, we'll look at the big picture, the protocol and the overall architecture. Then we'll get into the nitty-gritty of the server development framework. After that, we'll flip the script and explore the client side. And finally, we'll wrap up by looking at the command line interface and some of the really handy shared utilities.
Okay, first up, the protocol and SDK architecture. At its core, this whole SDK is built on a classic client-server model, and you can see this reflected right in the code, with the main logic living inside the /src/model context protocol directory.
So you're going to hear the term Model Context Protocol, or MCP, a lot. What does it actually mean? Well, think of it as a common language that lets apps and LLMs communicate clearly. It defines how to represent three main capabilities: tools the LLM can execute, resources it can access for information, and reusable prompts it can use. And if you're curious, the Pydantic models that define all these structures are right there in /src/model context protocol /models.py.
And as I mentioned, the high-level architecture is a client-server framework. This separation is super clear in the codebase. You'll find the core logic for all the server-side components in SRC model context protocol /server, while everything for the client side is neatly organized in SRC model context protocol /client.
Let's quickly trace the communication flow. It all starts with a client, using a client session connecting to a server's server session. This connection happens over a transport layer, and you've got options like STDO, HTTP, and WebSockets, which you'll find in the /source/model context protocol /transports directory. And the actual language they speak is JSON RPC, with all the messages structured and validated by those Pydantic models we talked about.
All right, that was the high-level view. Now let's put on our developer hats and dig into the server development framework. We'll be focusing on the components found in that /src/model context protocol /server directory.
So, when you're building a server, you basically have two paths you can take. There's the low-level server class, which gives you really fine-grained control over every little detail. But for most cases, you'll likely want to use the high-level fast MCP class. It's a much simpler, more ergonomic abstraction that really speeds up development. You can find its code in source/model context protocol /fast MCP.
The Fast MCP framework is built around three core managers that do the heavy lifting. You have the tool manager, which handles registering and running your tools. Then there's the resource manager, which, you guessed it, manages access to all your data resources. And finally, the prompt manager takes care of defining and using your prompt templates. All of their implementations live inside that Fast MCP directory.
Now, how do the client and server actually talk? The SDK supports several communication transports, each for a different use case. You've got Stedio for when the client and server are running on the same machine, like a child process. There's SDDI for simple one-way streaming on the web. Streamable HTTP gives you robust two-way web communication. And, of course, WebSocket for when you need a persistent, real-time connection.
Security is obviously critical, and it's handled using OAuth 2.0. You can set up your server as a resource server using middleware, which you can find in /src/model context protocol /server /security.py. In a nutshell, this middleware intercepts incoming requests, validates the bearer token, checks that it has the right permissions or scopes, and then makes that validated user information available to your app.
Okay, we've covered the server. Now, let's switch over to the other side of the conversation and talk about the client development framework, with its code located in /src/model context protocol /client.
The absolute star of the show on the client side is the client session class. Think of it as your main control center. It manages the entire request and response lifecycle, it can handle requests that are initiated by the server, and it even validates the results from any tools that were run.
But what if you need to talk to more than one MCP server at a time? That's where the client session group comes in. It's a really powerful feature that aggregates all the capabilities, the tools, resources, and prompts from multiple servers and presents them to you through a single unified interface. It makes working with distributed services so much simpler.
The client, of course, also needs to handle its side of the OAuth 2.0 security flow. The components for this are in /source/model/context/protocol/client/oauth.py. It supports the full authorization code flow with PKCE for security, and it takes care of things like endpoint discovery, exchanging the code for tokens, securely storing those tokens, and even automatically refreshing them when they expire.
All right, for our final section, we're going to look at some of the tools that make a developer's life easier, the command line interface, and the shared utilities you'll find in the library.
The CLI provides three main commands. MCP dev is your best friend during development. It's designed to work with the MCP inspector for debugging. MCP run is for when you just want to run a server directly. And MCP install is a specific command for integrating a server into the cloud desktop application.
One of the really neat shared utilities, located in source model context protocol lib proc.py, is for cross-platform process management. This ensures that when your application starts and stops subprocesses, it does so cleanly on any OS. For systems like Linux and Mac OS, it uses process groups and signals. For Windows, it leverages something called job objects. Different methods, but the same reliable result.
And the lib directory is just full of these useful building blocks. There's a factory for creating pre-configured HTTP clients, a whole set of pydantic models for OAuth 2.0 data, a request context data class to keep request info organized, a custom MCP error for better error reporting, and even an in-memory transport you can use for testing without needing a real network connection.
So, as you can see, the Model Context Protocol/Python SDK is much more than just a library. It's a complete protocol-driven framework. The clear separation of concerns between the protocol, the transport, and the application itself really facilitates building robust, scalable, and reliable integrations. And that really leads to the key question to think about. How does this structured approach enable more reliable and scalable integrations between applications and large language models?